Hello and welcome. This is Aryan Choudhary and you are watching Let's Crack JEE. ठीक है, मैं एक बार वापस प्रॉपर्ली चेक कर लेता हूँ that I am properly audible. Okay guys. So let's start our today's session that is on alkyl halide. Okay. So this is the sixth lesson on alkyl halide. I have taken 5 lessons. तो अगर आपने वो वीडियोस नहीं देखे हैं तो I would recommend पहले आप जाके वो वीडियोस देख लीजिए. Okay. So last lesson was on Grignard reagent. So I hope सबने वो वीडियो तो देख लिया होगा. And after that, yesterday I had taken a special class in which we have solved a lot of questions on Grignard reagent as well as अपन ने वहाँ पे बहुत फास्टली theory भी रिवाइज किया था. Okay, so we'll continue our alkyl halide chapter from today's session. तो आज के सेशन में ना what we will do is we have done the preparation, right? So अपन क्या करेंगे, we'll see a lot of reactions of alkyl halide and at the same time उसके बाद अपन aryl halide, we will see the basics of aryl halide, we'll see the preparation of aryl halide, and in tomorrow's session अपन उसके बहुत सारे reactions भी देखेंगे. So those of you who are seeing my video for the first time, okay, I am Aryan Choudhary. I cleared JEE in the year 2016. Okay, and I got admitted into one of the most prestigious college, that was IIT Dhanbad. तो मैं 2020 का pass out हूँ. Okay, so let's start our session. So first let's talk about the plus subscription. So you know right now we are studying on YouTube, right? So यहाँ पे ना अपना interaction properly हो नहीं पाता है. So the thing is, those of you who want a platform जहाँ पे आपको classroom वाला environment मिले, they should definitely take the plus subscription. I will tell you about the things that you get from the subscription. ठीक है, उसके बाद अपन ये भी देखेंगे कि like how to take the subscription. So the thing is, with the plus subscription you will be in a space जहाँ पे ना आपको पूरा क्लासरूम वाला फील आएगा. ओके, सो यू कैन डायरेक्टली इंटरेक्ट विद टीचर्स, आप उनसे डाउट्स पूछ सकते हो, आप उनसे कुछ भी डिस्कस कर सकते हो. एंड अपार्ट फ्रॉम यू देयर विल बी अ लॉट ऑफ अदर स्टूडेंट्स टू. तो आपको पूरा क्लासरूम वाला फील रहेगा. ठीक है, नेक्स्ट थिंग इज स्ट्रक्चर्ड कोर्सेज. तो द थिंग इज जेई का सिलेबस बहुत बड़ा है यार. सो मुझे पता है, लाइक सिंस आई क्लियर जेई इन द 2016, तो आई नो द पेन. तो बहुत बार ऐसा होता है ना कि अपन सुबह उठते हैं और अपने को समझ भी नहीं आता यार कि ओह आज क्या पढ़ना चाहिए. सो दैट इज़ वाई इट्स वेरी इंपॉर्टेंट टू हैव द कोर्स स्ट्रक्चर इन सच अ वे दैट कि आपका सारा चीज़ कवर हो रहा है, प्रॉपर टाइम पे कवर हो रहा है, आपको पता होना चाहिए कि आप इसके बाद क्या पढ़ने वाले. सो ऑल ऑफ दोज थिंग्स विल बी कवर्ड बाय अस. एंड द बेस्ट पार्ट अबाउट दिस प्लस सब्सक्रिप्शन इज लाइव टेस्ट एंड क्विजेस, है ना. द थिंग इज कि सिंस in your JEE you just need to solve those questions to get into an IIT, right? So you need to get into a habit of practicing those questions, right? So आपके ना weekly basis पे, monthly basis पे you will have a lot of different examination, जिसके basis पे you can evaluate whether you have studied that topic properly or not. And if you haven't, तो आप क्या कर सकते हो, you can go back to the Unacademy app and you can watch as many videos on that particular topic, right? And the thing is, in 2 years you will be giving more than 100 tests. So when you will go to give your JEE mains, तो आप उस टाइम तक कैसे you have got into a habit of giving these papers, so that will be very helpful to you. Okay, चलिए now let's talk about like how to take the subscription. Okay, so the first step is download the Unacademy learning app from the Play Store. Once you have done that, this is the main thing. यहाँ पे ना आपको एक plan choose करना है खुद के लिए. So the first step is you need to plan whether you want to take the plus subscription or the iconic. So iconic हमने बहुत recently we have launched the subscription. So firstly we'll talk about the plus. तो अभी लास्ट स्लाइड पे ना मैंने आपको प्लस के बेनिफिट्स बताए. So all of these things will be provided to you once you take the plus subscription. So the thing is generally ना मैं आपको 1 year या 2 year का सब्सक्रिप्शन लेना रिकमेंड करता हूँ, because you need at least this much time to prepare for JEE, right? For 1 year the price is 34,650 once you use my code which is AC01. This is giving you 10% discount. At the same time अगर आप 2 year का सब्सक्रिप्शन लेने का प्लान कर रहे हो, the price will drop to 50,400, again a 10% discount once you use my code which is AC01. So we have discussed about the plus. Now next thing is your iconic subscription. So the thing is, देखो there are a lot of students ना जिनको एक personal coach चाहिए रहता है, you need personal tutoring, right? So for all of you we have launched this subscription, that is the iconic subscription. यहाँ पे आपको हर step में will be providing you a teacher that will help you, that will guide you through the process. So you will have a personal coach. you will have a study partner, ठीक है. You will be provided with the guidance every time, like once a while we'll be talking to you and we'll be asking about the things that you were doing in the like whether you are facing any problem or not, ठीक है. And this part again, the test analysis. Finally, जब अपन एग्जाम देते हैं तो it's very important to do the test analysis afterwards, right? उससे अपने को समझ में आएगा ना कि अपन कहाँ पे लैग कर रहे हैं. So you will get the test analysis with a particular teacher, है ना. So everything will be provided. So the cost will be 50,400 for a 1 year plan and it will be 77,400 for a 2 year plan. So again you are getting this 10% discount here in both of these cases. And you still have any doubts regarding the plus or the iconic subscription, you can let me know in the chat box. Okay, so whenever I'm looking in this direction, I'm looking towards the chat box. Chali, let's start our today's topic, that is alkyl halide. This is the 6th lecture guys. Okay, so in this session we will be seeing reactions of alkyl halide. Okay, so let's begin our session. The first thing that we will see is we will see the coupling reaction. Okay, so in the coupling reaction, this is normally the fusion of two things. Coupling is taking two things and making one, right? That is coupling. So the first reaction that we will see is the Woods reaction. So Woods reaction अपन क्या करते हैं ना, we take any alkyl halide. Let's say we are taking this RX. अपन simply we add sodium to it. This RX will combine with one of the other RX to give you final alkane. So this is the alkane that we are getting. So this is leaving, this thing is leaving, and you are getting an alkane. We will see the reaction mechanism of this reaction in a while. तो यहाँ पे ना बस यहाँ पे अभी सिंपल चीज़ ये है कि alkyl halide में अगर आप सोडियम डालोगे तो दो alkyl halide रिएक्ट करके they will give you alkane. Okay, again this is very important. And the conditions here is dry ether. Okay, तो अभी जैसे अपन reaction mechanism करेंगे ना तो you will understand कि why you need a dry condition for this reaction. So this is one of the very common method to prepare your alkane from your alkyl halide. Okay, चलिए we will see one more example here. Here what you have is you have C2H5Cl. So we are taking alkyl chloride, we are adding sodium to it, है ना. So two equivalent of alkyl halide are reacting to give butane. So अपन ने किससे स्टार्ट किया था, we started with chloroethane. Okay, so let's try to understand the mechanism. देखो अपन सोडियम यूज कर रहे हैं. We know that your alkali metal can easily convert into positive charge and giving up a electron. ठीक है, so this is the first step. Now the bond between your carbon and halogen, यहाँ पे ना this bond break homolytically, ये homolytically break होता है, ठीक है. तो you will get a R radical and you will this electron that we have generated from sodium will react with this halogen to create this thing. Okay, so this was the first step. Using this is the use of sodium. The sodium is providing us with the electron. ठीक है. In the second step, this bond broke homolytically. ठीक है. And this electron combined with this halogen to create X negative. Now the thing is, we have created a free radical, right? We know that free radicals are very reactive, right? So since we have created this free radical, this free radical has a tendency to react with anything that will provide it with electron, right? So यहाँ पे आपके क्या होंगे कि इसकी मीडियम में there will be more of R radical, right? So this R radical and this R radical will combine. ठीक है, ये भी R radical similar process से ही बना रहेगा. This will combine to give your final alkane. Okay, again this reaction is type of a step up reaction. Step up reactions वही reactions होते हैं जहाँ पे you are getting more number of carbon from what you have started in the रिएजेंट। सो आपका जो चेन है ना, चेन इंक्रीज हो जाता है। लाइक दिस इज अ 4 मेंबर, दिस वुड हैव बीन अ 4 मेंबर रिंग अगर अपन 2 मेंबर रिंग से स्टार्ट करते, सॉरी, इफ वी वुड हैव स्टार्टेड विथ टू कार्बन इन अ चेन। सो अगर अपन स्टार्ट करते C2H5 लेट्स से Cl, है ना, तो यहाँ पे यू हैव 2 कार्बन्स एंड इन द फाइनल प्रोडक्ट यू विल गेट दिस थिंग, यू हैव 4 कार्बन्स। Okay, so I hope this part of the reaction is clear to everyone. The important thing about this reaction is it is a free radical reaction mechanism. The reaction mechanism here is free radical. Okay. Next thing is you will be forming a symmetrical alkene in this case. Sorry, symmetrical alkane in this case. यहाँ पे अपन क्या कर रहे हैं, वी आर जनरेटिंग अ सिमेट्रिकल एल्केन। ठीक है, अपन जस्ट देखेंगे लाइक व्हाई वी आर जनरेटिंग ओनली सिमेट्रिकल एल्केन। आई गेस रिएक्शन मैकेनिज्म तो सबको समझ में आ गया होगा। नाउ लेट्स ट्राई टू अंडरस्टैंड दीज 2 पॉइंट्स आर वेरी इंपॉर्टेंट। द फर्स्ट पॉइंट इज Wood's reaction is mainly used for self-coupling. Oh, okay. Okay, chaliye, let's discuss these 2 points. The first point is Wood's reaction is mainly used for self-coupling. ठीक है, what do I mean by this statement is कि आपका ना, if you take one of the alkyl halide, ठीक है, and we are adding sodium to it, the second one should be this Rx only. You cannot have 2 different, that is one Rx and you will use another R-X. Okay, ये reactions are not favorable by this reaction mechanism, and the reason is, देखो reason क्या है, देखो we are creating free radical, right? So let's try to do this reaction, that is the reaction where you are taking 2 different alkyl halide, that is you are trying to do cross coupling. सिंपल वाले का एग्जाम्पल तो अपन ने देख लिया है ना, वी हैव सीन दिस रिएक्शन. Now in this case what will happen is, let's take one example of CH3Br, okay, and here, let's say we have C2H5Br. So these two are the 2 different alkyl halide that we are starting with. Now the thing is, अपन ने देखा कि finally we are creating a R radical. So from here you will create a CH3 radical, and from here you are creating C2H5 radical. Now the thing is, we know that कि आपके जो free radicals है ना, these are very reactive. Now this CH3 radical has 2 choices. Either it can react with one of the other CH3 radical, or it can react with C2H5 radical. So if this reaction will happen, so you will create this thing. अब मैं bond line formula draw कर रहा हूँ. This represents 2 carbon, right? But if this will combine with this thing, so you will have a 3 carbon in the chain, है ना? Similarly, this has 2 options. You can either it will react with CH3 radical to give the same this product, that is a 3-membered ring, or it can react with another C2H5 radical to form a 4-membered ring, sorry, a 4-membered chain. Okay, so the thing is, we are getting 3 different alkane. Okay, so देखो, since all of them are alkane and these alkanes are present in the homologous series, so this is a 2-membered alkane, this is a 3-membered and this is 4-membered, तो इनका boiling point and melting point भी almost similar होता है. So इनको distinguish करना would be very difficult. अपन कभी भी कोई reaction करते हैं ना, तो we try to do the reaction in such a way that कि अपना एक product जो अपना एम है ना, अपने को बस वही ज़्यादा क्वांटिटी में मिले. दैट इज़ वाई वी ऑलवेज टॉक अबाउट द मेजर प्रोडक्ट. क्योंकि जब भी आप कोई रिएक्शन कर रहे हो तो ऑब्वियसली आपका एम होगा ना कि या मेरे को ये वाला फाइनल प्रोडक्ट चाहिए, तो उसके अलावा जितनी भी चीज़ें आपके पास एक्स्ट्रा बनती है, सारे कचरा, सब कुछ कचरा होगा. सो ऑब्वियसली विल नॉट बी नीडिंग ऑल ऑफ दोज थिंग्स. ठीक है, सो इन योर क्रॉस कपलिंग रिएक्शंस द प्रोडक्ट्स दैट वी आर गेटिंग आर वे टू मच, ठीक है, एंड इनको डिस्टिंग्विश करना विल बी वेरी मच डिफिकल्ट. So that is why we prefer in the Woods reaction we only make the product from self coupling, and your self coupling reactions will always give you symmetrical alkane, है ना. Let's take one example. Let's say you started with this thing, ठीक है. If you start with this thing, you will get a structure that will look something like this. So you have the structure is symmetrical, right? So these two points are very important. Mark these points. Moving on to the next thing. Now what we will do is we will try to take few examples, ठीक है. अपन कुछ examples करते हैं and we will try to make different products, ठीक है. So we'll see few examples of your Woods reaction. So this is the first reaction. देखो एक चीज़ बताना मैं भूल गया. The thing is, okay, just wait for a minute. मेरा इंटरनेट प्रॉपर नहीं चल रहा है शायद, so I'm not able to see the chat box. Okay. चलिए, द थिंग वॉज, मैंने स्टार्टिंग में बताया था द यू नीड ड्राई ईथर इन दिस केस टू. अपन ने कल ग्रिग्नार्ड रिएजेंट का रिएक्शन किया था, वहाँ पे भी अपन ने देखा था दैट दिस कंडीशन वॉज वेरी इंपॉर्टेंट इन द केस ऑफ ग्रिग्नार्ड रिएजेंट. हियर ऑल्सो द थिंग इज, since the reaction is going via free radical reaction mechanism, this can react with any H radical from the medium. Okay, so that is why you need the whole thing कि आपके पास यहाँ पे कुछ भी मॉइस्चर नहीं हो. द कंडीशन शुड बी ड्राई. ओके, चलो लेट्स ट्राई टू डू दिस एग्जाम्पल. देखो आपके पास जब भी ऐसे क्वेश्चन आए, यू ऑलवेज नीड टू ड्रॉ द फ्री रेडिकल. वंस ड्रॉ द फ्री रेडिकल, उसके बाद देखो कि व्हाट आर द डिफरेंट पॉसिबिलिटीज. ठीक है, सिंपली देखो, सिंस वी आर यूजिंग सोडियम, दिस इज अ रिएक्शन जहाँ पे आपका इंट्रामोलिकुलर रिएक्शन भी पॉसिबल है ना. तो लेट्स ट्राई टू डू इट. इन द फर्स्ट स्टेप व्हाट वी विल डू इज वी विल रिमूव बोथ द क्लोरीन. ठीक है, क्लोरीन दोनों चले गए, एंड दिस सोडियम हैज प्रोवाइडेड, so you will have a free radical on both of these carbons. Now the thing is, these two carbons have different options. ठीक है, एक चीज़ जो यहाँ पे हो सकती है वो कि this can combine with another CH2. Okay, this will combine with this itself to form the structure that is a cyclobutane. एक और चीज़ यहाँ पे हो सकती है, ठीक है, ये डायरेक्टली ये डबल बॉन्ड भी बना सकते थे. you will have a alkene here. Okay, so you can create a cyclobutane, you can get a cyclobutane as well as you will get a alkene from this reaction. Now the thing is, देखो, out of these two, this reaction will be the faster reaction because it's very easy to create your alkene, right? वहीं पे अगर आप साइक्लोब्यूटेन की बात करो तो दिस स्ट्रक्चर, दिस इज नॉट स्टेबल, राइट? यू हैव रिंग स्ट्रेन हियर. वी हैव सीन इन आइसोमेरिज्म दैट योर साइक्लोब्यूटेन इज नॉट प्लेनर, है ना. वो वन ऑफ द कार्बन इज बेंडेड, राइट, टू compensate the ring strain as well as your torsional strain. So generally you will get this alkene as the major product while this will be in the minor. So this is the result of your intramolecular reaction जहाँ पे आपका same molecule के अंदर reaction हो गया. This is the result of intramolecular and this is your intermolecular. चलिए let's move on to the next thing. So what will happen if you have two chlorine bonded to the same carbon? So ऐसे केसेस में क्या करोगे? So again you are putting sodium in dry ether condition. So as I have told you, in all of these questions, in the first step, what you need to do is you need to prepare the free radical. So from here, what we will create is, ये एक्चुअल में क्रिएट नहीं होगा, एक एक करके क्लोरीन लीव करेंगे, राइट? सो फिर भी ना अपन क्या करते हैं, फॉर आवर कन्वीनियंस अपन क्या करते हैं, लेट्स अज्यूम दैट बोथ ऑफ द क्लोरीन लीव क्रिएटिंग दिस थिंग. This is your carbene like structure. So this is not actually forming here, but eventually इस टाइप आप रिएक्शन में ऐसा कंसिडर कर सकते हो, ठीक है. नाउ व्हाट कैन हैपन हियर इज, आपके पास एक और ऐसा हो सकता है, राइट? यू कुड हैव दिस थिंग इन द सोल्यूशन. सो दीज टू विल फॉर्म अ डबल बॉन्ड टू क्रिएट दिस स्ट्रक्चर. Say here in all of these reactions we are not doing cross coupling, it is only self coupling. It's just that यहाँ पे आपका like in the previous case यहाँ पे आपका intramolecular self coupling हो रहा था, while यहाँ पे you were creating intermolecular self coupling. तो आपके पास ऐसा भी कुछ तो रिएक्शन हो सकता था. You could have these things, यहाँ पे क्लोरीन, यहाँ पे क्लोरीन. तो आफ्टर if you had this thing, तो आप ये create करते, you would have created this thing, right? Now this could either convert into an alkene, और ये एक मिनट, ये ऐसे एक और मॉलिक्यूल के साथ रिएक्ट करके ऐसा कुछ तो बना देता. So you would have got this thing as the final product, ठीक है. So simple there. Here you could get two different products. But in this case यहाँ पे देखो, it is not possible to have the intra molecular attack. So यहाँ पे आपका इंटर वाला ही होगा and you will get this as the major product. Simply हाँ यार, डायरेक्टली डबल बॉन्ड यहाँ पे नहीं आएगा. In the first step this chlorine will leave to create this thing, CH3 hydrogen, a chlorine and a radical, right? So this will combine with this thing. You will have a single bond in the first step. Now this chlorine will leave in the second step. Okay, once you have created, okay, तो यहाँ पे आपका what you are doing here is, यहाँ पे आपका first chlorine is leaving, यहाँ पे first reaction is your inter reaction, while the second one is your intra. Once you have reached here, इसके बाद आपका intra reaction होगा, this chlorine will leave, right? So यहाँ पे आपका inter भी हो सकता है, but that will be very difficult. बहुत सारे products बन सकते हैं. So you'll not consider that. ये रिएक्शन इतने फास्ट होते हैं कि once you have reached here, आपका these two chlorine will leave to give this as the final product. Okay. चलो, moving on to the next thing. This is important. So what will happen here? Again, what we have learned अभी थोड़ी देर पहले कि in the first step just make those chlorine leave, create the free radical. So you will create this free radical once the chlorine will be gone. Now there are two different reactions that can happen. यहाँ पे one thing that you can have is these two will react with each other to form a three-membered ring. You always remember कि आपके ना जो इंट्रा रिएक्शंस होते हैं ना, ये बहुत फास्ट होते हैं. इसको वेट नहीं करना पड़ रहा है कि कोई एक और बंदा आएगा और उसके साथ मैं रिएक्ट करूँगी या करूँगा. ये डायरेक्टली खुद के साथ रिएक्ट कर सकता है. दिस कैन डायरेक्टली रिएक्ट विद ईच अदर. तो बिल्कुल वेट नहीं करना पड़ रहा है, राइट? वाइल द अदर थिंग दैट कैन हैपन हियर इज you have this radical, at the same time you will have one more of this in the solution. So from here what you can have is you can create a 6-membered ring. You have created, I will draw, इसको थोड़ा सही से ड्रॉ करता हूँ. You have created this, that is your cyclohexane. Okay, now between your cyclopropane and cyclohexane, this is less stable, this is more stable. We know that 6-membered ring are very stable. They they remain in chair conformer, right? This is more stable. Now the thing is, since this is a intra reaction, this will be a faster reaction. This will be a faster reaction. ठीक है, since it is a faster reaction, this is your kinetic major product. So kinetically you will get this thing as a major product. Okay, but if you think about thermodynamically, that is, if you provide a lot of heat, so thermodynamic reactions only concern about the final product. ठीक है, आराम से जो फाइनली लास्ट में बन रहा है. while your kinetics में we talk about the speed, the rate of the reaction, right? So this reaction is fast, right? This is a very fast reaction, but the product that we are getting is less stable than the slow reaction. So this your thermodynamically major product is more stable. Okay, so I hope this thing is clear. Now if you provide more heat to this reaction, let's say we are keeping the temperature very high, so under high temperature your thermodynamic products are favored. So if you increase the temperature of the reaction, you will get more of the cyclohexane, while at lower temperature you will get this kinetic major product, that is your cyclopropane. Okay, okay, this is an important reaction. ठीक है, यहाँ पे this example is a very good example. Here you need to understand कि यहाँ पे आपके reactions क्या क्या हो सकते हैं. So let's say अपने पास ना ऐसे दो molecule है, right? So we are taking two of these molecules. I will draw both of them here. Okay, this is the first molecule and this is the second one. Okay, मैंने थोड़ा weird draw कर दिया. चलो, now the thing is, in the first step what is happening is अपन ने देखा था in the Wood's reaction, the first step is after creating electron, this bond will break homolytically, right? Now between you have to pick a choice. यहाँ पे आपको the first thing that you need to do is you need to understand whether this bond will open up homolytically or this bond will open up. Okay, now since we know that carbon chlorine bond are more stable, that is your bromine is a better leaving group. That is your bromine is a better leaving group. So what can happen is you will create this thing, you will have a radical here, and again this bromine will leave to create this radical. ठीक है, अभी यहाँ पे क्या हो सकता है मुझे बताओ. Now one thing that can easily be done here is these two will react with each other to create you will have chlorine on both sides. Here you have this thing. So this will be the major product from this reaction. Since your carbon bromine bonds are not that stable, so that is the radical, this is the free radical that will be generating. Okay, but there is one more possibility that can happen here. देखो क्लोरीन का लीव होना that is very difficult. वो तो होना बिल्कुल भी पॉसिबल नहीं कि ब्रोमीन रह गया and you are leaving your both the chlorine has left. ठीक है, अभी एक और पॉसिबिलिटी है कि let's say we have provided a lot of temperature, I will write it here, a lot of temperature, that is, or you can say a lot of heat. So in that case what would happen is अगर अपन बहुत ज़्यादा heat provide कर रहे हैं ना, तो ये जो बॉन्ड है ना ये भी ब्रेक हो सकता है. This bond will break, your chlorine will leave. Okay, this is homolytical. Okay, so once it will happen, so what you will create is you will create this thing. ठीक है, since you have created these things, you have free radical here and a free radical here, so these two can react to form this thing. This is very rarely, ये form करना बहुत difficult है, very difficult to form. Okay, so generally you will get this as the major product. This will be very slight. Okay, so right now guys, what we did is we tried to understand the Wood's reaction in different reaction. अपन ने पहले समझ लिया कि what is the basic concept behind your Wood's reaction, and after that we have seen a lot of different reactions जहाँ पे we are using the concept of Wood's reaction. तो यहाँ पे with these examples अपने को समझ में आया कि you can have different products. So these three examples were very important. Okay. Moving on to the next thing, that is your next reaction, that is your Corey-House synthesis. This reaction is again a organometallic reaction. यहाँ पे भी we are doing the same thing, we are doing coupling, right? अभी अपन ने we have seen in the case of Wood's reaction कि वहाँ पे we were doing only self coupling, right? So Wood's reaction was only favorable for self coupling. अगर if you try to form क्रॉस कपलिंग प्रोडक्ट्स तो आपके पास बहुत सारे प्रोडक्ट्स बन रहे थे एंड इट वाज वेरी डिफिकल्ट टू सेपरेट देम. So that is why we use a different method, that is your Corey-House synthesis, which is used to form your cross coupling reactions, or I would say cross coupling alkanes. Okay, so what we do in this reaction, we first take any alkyl halide. ठीक है, it could be a 1 degree, 2 degree or 3 degree, right? We react with lithium to give us RLi plus Li plus X minus. So you will use 2 of the lithium. So this is creating an alkyl lithium. ठीक है, you are creating an alkyl lithium and you will have LiX. Now the thing is this RLi, if you take 2 of these, let's take we are using 2 of these and we are reacting with CuI. So we are right now what we are doing is we are seeing the preparation of the Corey-House, the reagent of Corey-House synthesis, that is also known as Gilman reagent. So in the first step we have seen we are reacting it with lithium. ठीक है, after reacting with lithium we have formed RLi, and once you take 2 of the RLi and react it with CuI, अगर आप CuI के साथ react करोगे तो what you will get is, आपका देखो lithium and this iodine will react with each other to form Li plus I minus, while this thing R2LiCu, this is known as your Gilman's reagent, or the reagent that we use in Corey-House synthesis. So R2Cu Li is the Gilman's reagent. I guess I am properly live. मेरे फ़ोन में थोड़ा मेरे शायद फ़ोन में इंटरनेट का प्रॉब्लम है, तो मुझे लगा कि we are not properly live. So let me check once again. Let me know in the chat whether I am properly audible or visible if someone is watching. Okay, we are properly live. No issue with the live thing. चलिए, so we were discussing Corey-House synthesis, right? So देखो, finally we have created our reagent in the Corey-House process. It is R2CuLi. This is again a reagent which is something like your Grignard reagent, and both of these reagents are also known as organometallic reagent. And once you have created this, now you can react this R2CuLi with any Rx to create, let's say this is your R dash, to create a R dash. Okay, the only thing which is important is the R dash X that we are using here must be a 1 degree. ठीक है, should be a 1 degree alkane. Yeah, hi Rupal. Okay, so अपन देखेंगे कि like why it should be a 1 degree alkane in the next page. The thing is, this reaction is a SN2 reaction. This is very important. Write down, please write down, guys. Start making notes of these things. The thing with the organic chemistry is you need to revise the concept once in a while, है ना. तो आपके पास अगर प्रॉपर नोट्स होंगे ना तो रिवाइज करना बहुत ईजी हो जाता है. So just write it down. That is your Corey-House synthesis reaction is a SN2 reaction. This mechanism here is via your SN2 reaction mechanism. So the starting alkyl halide that we are using can be a 1 degree, 2 degree or 3 degree, but here the R dash that we are using should be a 1 degree alkyl halide. The thing is, देखो finally यहाँ से क्या कर रहे हैं अपन, we are replacing this R dash X का bond with a R. So eventually you can consider this like you are getting a R negative from here, है ना. जैसा अपन ने Grignard reagent में देखा था ना, that we were creating a R negative. So we are creating a same type of species in the Corey-House synthesis too. So yeah, you are creating this R radical. This will attack on this Rx to give R dash. Now since this is happening via SN2 reaction mechanism, है ना, and we know that for SN2 reaction mechanism you need, this is the order, right? That is, your 1 degree alkyl halide will readily go SN2 reaction, will do SN2 reaction mechanism. So that is why this is important. Let's try to understand with the help of one example. देखो यहाँ पे this is the R dash X, right? So we are taking this Glimann's reagent, है ना. So this is the this can act as this thing. Okay, now once you have created this, what we have seen कि देखो कल के लेक्चर में, sorry, in Friday's lecture we have seen कि आपके जो Grignard reagent होते हैं ना, उनकी जो प्रॉपर्टी होती है, इट कैन एक्ट एज अ बेस और अ न्यूक्लियोफाइल. Similarly, this will here will also can act as a base or a nucleophile. But here the thing is, इसके पास एक ही चॉइस है, इट कैन ओनली एक्ट एज अ न्यूक्लियोफाइल. जनरली क्या होता है ना कि सिंस कार्बन एज अ नेगेटिव चार्ज, तो इनकी बेसिक टेंडेंसी बहुत ज़्यादा इंक्रीज हो जाती है. सो इफ दे कैन एक्ट एज अ बेस, तो वो प्रेफर करते हैं कि वो बेस जैसा एक्ट करें. बट यहाँ पे दे डोंट हैव अ चॉइस, दे नीड टू एक्ट एज अ न्यूक्लियोफाइल. नाउ द रिएक्शन इज हैपनिंग वाया योर SN2 reaction mechanism. So this carbon will attack on this carbon and this bromine will leave, right, creating this as the final product. Okay, I hope this part of the reaction is clear to everyone. We will see one more example to understand more about the Corey-House synthesis. तो यहाँ पे बिफोर डूइंग दिस अपन ने ठीक है एक बड़ा एग्जाम्पल ले लिया, बट एक छोटे एग्जाम्पल के लिए मैं आपको बहुत सिंपल वे में समझाता हूँ. यू कुड हैव यूज्ड CH3 होल ट्वाइस CuLi प्लस C2H5 chlorine. This is a 1 degree alkyl halide, right? So these two will react to form a 3 carbon chain, right? You will get propane from here. So you have achieved unsymmetrical alkane, right? So we have seen कि अपन in the Woods reaction we were only able to prepare your symmetrical alkane. तो unsymmetrical alkane बनाने के लिए we always use this process, that is your Corey-House synthesis. Similarly, I hope सबको ये वाला example समझ में आया कि why you need a 1 degree alkyl halide. यहाँ पे on this carbon the attack is happening. Okay, yeah, a lot of you would be wondering that yeah, this is a very bulky nucleophile, है ना. So we know that bulky nucleophile try to act as a base, right? But यहाँ पे basic acidic कुछ है ही नहीं, like you cannot have acid base reaction. So ये मजबूर है to act as a nucleophile. Okay, next thing is this reaction. So here what we have is, देखो यहाँ पे we have this Glimann's reagent, right? So यहाँ से what we are creating is we are creating this CH3 radical. Now what this CH3 radical can do, अपना जो alkyl halide है, ये जो है the carbon जिस पे अटैक हो रहा है, दिस कार्बन, यहाँ पे भी अपने को पता है द अटैक शुड बी SN2 अटैक, सो आपको बैक साइड अटैक करना है, दिस इज लीविंग राइट, बट पीछे से तो स्पेस ही नहीं है, so this CS3 minus will not be able to attack on this carbon. Rather, what it can do is it will act as a base. It can capture any of the hydrogen. Let's say here we have a hydrogen, so this will try to capture this hydrogen. ठीक है, तो यहाँ पे जो आपका जो रिएक्शन होगा वो आपका E2 रिएक्शन हो सकता है. This nucleophile will capture this hydrogen and this bromine will leave, right? यहाँ पे you will create a positive charge, here you will have a negative charge, तो आपका simply you will get alkene as the major product. So this is the alkene that we are forming. Okay, so यहाँ पे आपका elimination product is the major product. Okay, while substitution वाला you will get a very small amount of substitution. While यहाँ पे अपन ने देखा था कि if your alkyl halide जिसके ऊपर अटैक हो रहा है if it is a 1 degree alkyl halide, okay, तब आपका SN2 reaction mechanism easily हो सकता है ना, and you will get the substitution product. While if it is a 3 degree alkyl halide इस पे अटैक हो रहा है तो आपका elimination will be more favored. We have discussed this in the chapter of reaction mechanism. चलिए, moving on to the next thing. The next thing is your Frankland's reaction. So this is again one coupling reaction. ठीक है, अपन अभी तक अपन देख रहे थे कि we were using sodium, but apart from sodium you can also use zinc to do the same thing. So this is again like your Woods reaction. The only thing is वहाँ पे अपन sodium use कर रहे थे and here we are using zinc. We are getting the same symmetrical alkane. The conditions are same here too. It's just that Frankland ने सोचा कि मैं जिंक के साथ ट्राई करता हूँ and he tried it और reaction हो गया and his theory got published. So that is why we study this reaction. चलो, this is an important part of this chapter where we study the reaction of ammonia. Okay, so we have reached to that point of the chapter जहाँ पे अपन ने सारे preparation method देख लिया. We have studied very in depth about the concept of alkyl halide. So this is again one concept that is very important. You will see a lot of questions coming in your JEE on this topic, that is your reaction with ammonia, the alkyl halide's reaction with ammonia. So what can happen is, देखो यहाँ पे you are taking an alkyl halide, you are adding ammonia into the solution. ठीक है, once you will do that, आपके पास पता है, देखो जो नाइट्रोजन है ना, इसके पास लोन पेयर है, राइट. So what it can do is it can attack on this alkyl and this halogen can leave, creating a 1 degree amine. ठीक है, you have taken alkyl halide. Let's take one example, CS3Br, and we have reacted this with NH3. So what you will create from here is you will create CH3 NH2. ठीक है, once you have created this, आप देखोगे, नोटिस करोगे कि still this nitrogen has lone pairs, right? So let's say we are taking excess of alkyl halide. अपने पास ये बहुत सारा present है solution में, तो what can happen is this nitrogen's lone pair can again attack on one of the CH3Br. This bromine will leave, eventually creating a nitrogen which has CH3. यहाँ पे फिर you will lose one hydrogen. Okay, so you have 2 CH3 and a hydrogen, and again you have lone pair. Now again this can react with another CH3Br to form this structure. Okay, मैं यहाँ पे ड्रॉ करता हूँ, to form this structure, जहाँ पे आपके पास नाइट्रोजन के पास 3 कार्बन्स हैं. Okay, we have created this. We have also lost a hydrogen in the process to create the structure. Once you have reached here, now the thing is still you can notice that nitrogen has a lone pair. So यहाँ पे since we have excess of alkyl halide, you can again have a reaction of alkyl halide with this nitrogen. So once this will attack and there is no more hydrogen to lose, right? You don't have any hydrogen, so this nitrogen is forming 4 bonds. ठीक है, it is attached to 4 of the CH3s. ठीक है, so this nitrogen will carry a positive charge. And now the thing is, since it has a positive charge, so आपके पास solution में you also have a Br negative. So this whole thing where this nitrogen is having a positive charge on it is known as your quaternary ammonium salt. Salt because you have a positive charge and a negative charge next to each other. This is like a salt, right? So finally you have created this thing. So you will see a lot of different reactions जहाँ पे ना you will see a questions coming on quaternary ammonium salts. चलिए, moving on to the next thing, we have created quaternary ammonium salt. So देखो, अगर आप एक ही alkyl halide use करते तो you could have stopped here, but since we are using excess of alkyl halide, तो finally ना यहाँ पे आपके पास मिलता R4N positive Cl negative. Okay, this is the final product that we are obtaining. Next thing, okay, so we'll see few questions on your quaternary ammonium salt. I hope this part is clear to everyone. ठीक है, now the thing is, in the first step what we are doing is we are adding CH3. This is the question for you guys. एक बार आराम से क्वेश्चन देखो. देखो, once you have reacted with the alkyl halide with nitrogen, है ना, you will create the quaternary ammonium salt. And उसके बाद in the second step, this is the first step, right? In the second step we are adding moist Ag2 and heat, right? So this is the reaction, this is for your elimination reactions, right? So one of the bonds with the nitrogen is breaking in this second step. ठीक है, तो अपन let's try to do it here. So in the first step what you will have is you will have this nitrogen के पास देखो 2 बॉन्ड है, so it has 1 hydrogen, right? So in the first step this hydrogen we will replace this hydrogen with a CH3. And now the thing is you can also have one more reaction. आप एक और reaction यहाँ पे कर सकते हो. One more CH3 can add to this nitrogen. So the final thing that you will get is 1 2 3 4 5. So you have this thing, है ना? Okay, मैंने थोड़ा 4 मेंबर ड्रॉ कर दिया गलती से. ओके, कुछ तो प्रॉब्लम हो रहा है, तो लेट्स यहाँ पे ड्रॉ करते हैं यहाँ पर. तो यहाँ पे वी हैव, देखो वी हैव 4 कार्बन्स हियर, राइट? सो यहाँ पे यू विल हैव 1 CH3 and 1 more CH3 creating a positive charge on this nitrogen. So once we have created this thing, now what we are doing is we are adding moist Ag2O. So what it will do is it will make one of the hydrogen which is present on the beta position. It will take out that hydrogen to create a carbanion. We are creating a carbanion by taking one of the hydrogen which is present on the beta position. So the positions which are next to this nitrogen are alpha. These positions are alpha. ठीक है, this is the beta position, this is the beta position, and this is again a beta position. So I hope everyone knows about these things. So what it will do is it will take one of the hydrogen from the beta position, and the reason is, देखो यहाँ पे नाइट्रोजन को ना एक बॉन्ड ब्रेक करना है. Now the thing is nitrogen cannot break its bond with CH3. You cannot create a CH2 positive in the solution, right? This is not that stable. So this nitrogen has 2 options. So it can either break this bond or it can break this bond. तो यहाँ पे क्या होगा ना, when this bond will be broken, so since we are creating a carbanion, let's say आपके पास options कहाँ से, you have one option to create this carbanion. You can create this carbanion, or you can take out one of the hydrogen from here to create this carbanion. ठीक है. So you have all of these 3 options. In the first step we are creating a carbon ion, and in the second step, this is the first step, in the second step nitrogen carbon bonds breaks. Okay, so now you need to understand ki since we are creating a carbon ion in this case, we'll talk about the stability of these carbon ion. Now let's try to write here. This is a 1 degree carbon ion, this is a 2 degree carbon ion, and this is a 3 degree carbon ion. Okay, now we know that कि अपने 1 degree जो carbon ions होते हैं ना, these are more stable than your 2 degree, than your 3 degree. So that is why the hydrogen will be taken out from this place, and this bond will be broken. So once that bond will be broken, you will have this structure. ठीक है, यहाँ पे आपके पास एक डबल बॉन्ड होगा, and you will have a CH3 here. So यहाँ पे we have got a double bond. Okay, this is the alkene that we are creating. One more thing can be used instead of moist Ag2. Sorry. Okay, so instead of using moist Ag2 and heat, you could have used OH negative. It would have done the same thing. Okay, so you can create the rest of the products. देखो, this will be the major product that we will be getting. Yeah, you can replace one of the hydrogen from here. अगर यहाँ से अगर hydrogen replace होगा, तो you will get this alkene. This is the alkene that will obtain. So we know that this alkene is more stable than this alkene. है ना? This is more stable because this is more substituted, right? But still we get this as the major product, and the reason is since we are creating this carbon ion, the stability of this carbon ion is very important, because the first step is that step, and that is the rate determining step to create that carbon ion. I hope all of these things are clear to everyone. Okay, you will see a lot of questions coming on the topic of quaternary ammonium salt, but this is the only thing that you need to keep in your mind. So in the first step we are creating this carbon ion. Since we are creating this carbon ion, this order is very important. Okay, moving on to the next question. ठीक है, यहाँ पे क्या हो रहा है? This is the substrate that we are using. In the first step we are adding excess CH3I. ठीक है, we are doing the same thing. First thing is your reaction of alkyl halide with your nitrogen. So you will create a quaternary ammonium salt that will look something like this. You will have 1 CH3 and 2 CH3. There will be a positive charge on this nitrogen. Okay, so once you have created this, अभी अपन second step में क्या कर रहे हैं? In the second step we are adding moist Ag2O and heat. This is pointing towards your elimination reaction. Now the thing is, देखो, again this nitrogen cannot break its bond with these CH3s, right? So it does not break with this bond. So it has two options: either it will break this bond or it can break this bond. Since we have just talked that the only thing that on which this reaction depends is on the stability of carbon ion, तो आपको बस चेक करना है कि जहाँ पे भी आप कार्बन आयन बना रहे हो, तो which carbon ion is the more stable carbon ion. So here you will have a carbon ion which is a 2 degree carbon ion, but here you will create a 3 degree carbon ion. Now we know that 2 degree carbon ion are more stable than 3 degree, so that is why this bond will be broken. Okay, you will get this as the final product, or I would say the major product. You will have this thing. Okay, so this is the major product that we are getting. One more thing, let's take one more example to understand this concept. Let's take the same substrate. Okay, so if we are taking the same substrate, it's just that instead of using excess CH3I, what we will do is we'll be using C2H5I. Okay, so in this case what you will create after adding excess C2H5I, once you will add this excess, you will create this thing. Now the thing is, देखो, Now when I will add moist Ag2O or heat to this reaction, तो आपके पास बहुत सारे options हो गए. Now either this nitrogen can break this bond or it can break this bond. It can also break this bond, right? Both of these are similar, तो अपन एक पे draw करते हैं, है ना? It can break any of these one bond, right? Now the thing is you just need to check कि whether अपन ने इन दोनों में तो कंपेयर कर दिया था, ठीक है. नाउ लेट्स चेक, यहाँ पे अगर अपन हाइड्रोजन निकालेंगे तो व्हाट टाइप ऑफ कार्बन है विल वी बी गेटिंग. So here if the hydrogen will be removed, the carbon ion that we are generating is a 1 degree carbon ion, right? So your 1 degree carbon ion is more stable than your 2 degree. So यहाँ पे since we are creating a 1 degree, अपन ने ऊपर केस में देखा था that this was a, if this bond break you will create a 2 degree carbon ion, right? This is more stable. So यहाँ पे the product that you will be getting is this thing. So this question is very amazing. You will see a lot of questions coming on this topic. So बहुत simple concept है, but ऐसा है कि बहुत लोग गलती कर देते हैं. So you have this thing and you will have an alkene, that is your ethene. Okay, so this is what we are generating from this reaction. So this is a advanced level question. Okay, this is very important, guys. Okay, I guess all of this part is clear to everyone. The next thing is the reactions with cyanide and isocyanide. Now the thing is, since we are seeing the different reactions of alkyl halide, so this will be the last reactions of our today's session. Uske baad we'll talk about your aryl halide. In tomorrow's session we'll finish this chapter of alkyl halide. We'll see the bonds, we will see few more reactions, ठीक है? That is, one of the reaction is your Huntsdiker reaction, ठीक है? And we will see few more few reactions of your SNAR and all of that, and we'll be solving a bunch of questions too. So right now let's focus here. Let's talk about the reactions of cyanide and isocyanide with your alkyl halide. So the thing here will happen is, देखो, in the first case we are reacting your alkyl halide with KCN. So when you react with KCN, this is providing us with a K positive and a CN negative. This CN negative is the nucleophile here. Okay, this can attack on this halogen. This can replace this halogen of this R. So here what you have is the negative charge is on this carbon. This carbon is acting as a nucleophile, है ना? And finally you are bonding this R with C triple bond N. This is the final product we are obtaining when we are reacting alkyl halide with KCN. Okay, let's take one example. Let's take CH3 chloride and you will have KCN. So if you do this reaction, you will have CH3CN. Simple, very simple. Okay, next thing is, you can have any type of weird chloride. This is the chloride that we are having. If you add KCN to it, so you will have a cyanide here. Simply this is providing us with a negative charge on this carbon, which is acting as a nucleophile. But in the case of AgCN, what is happening here is कि आपका ना जो यहाँ पे देखो तो bond था ना, that was ionic bond. Okay, this was ionic, तो आपका ये बहुत easily create हो गया. But the thing between the bond between Ag and carbon, this bond is a covalent bond. So since it is a covalent bond, ये bond break करना is not easy. So यहाँ पे ना क्या हो रहा है कि ये जो नाइट्रोजन है ना, we know that this nitrogen has a lone pair. So when you react this AgCN with a alkyl halide, let's take one example. Let's take this alkyl halide only. यहाँ पे when you react this with AgCN, so what will happen is your carbon is not free. ये bond break ही नहीं हो रहा है. कार्बन के ऊपर नेगेटिव चार्ज ही नहीं है कि वो न्यूक्लियोफाइल की तरह एक्ट करे. So what will happen here is this nitrogen, which is having this lone pair, can attack on this carbon and this chlorine will leave. So in this case you will create a species that will look something like this. So that is the difference. We have seen the preparation of cyanide as well as isocyanide. Okay, it just depends upon the type of reagent that we are using. यहाँ पे the bond was ionic, तो आपके कार्बन के ऊपर नेगेटिव चार्ज था. But in the case of AgCN, since this bond is covalent, ये bond पहले break ही नहीं हो रहा है. The first step, this lone pair of nitrogen has to attack on the alkyl halide. So with this we have completed a lot of different reactions of this chapter, that is our alkyl halide. We have seen the coupling reactions. We have seen 3 different type of coupling reactions. पहले अपन ने बात किया था, we have seen the case of Woods reaction which is suitable only for your self coupling reactions. ठीक है. After that we have seen Gilman's reagent, that is a Corey House synthesis process, where we understood that it can be used to prepare your unsymmetrical alkene, that is via cross coupling, है ना. फिर अपन ने Franklin process भी देखा, that Franklin just used zinc instead of sodium. And after that we have seen a bunch of examples. ठीक है. अपन ने अमोनिया के साथ रिएक्शन देखा. This was very important guys. We have seen the preparation of quaternary ammonium salt. We have seen different way in which you can react your quaternary ammonium salt. And finally we have seen the reactions of cyanide and isocyanide. This is your cyanide. एक minute. This is your cyanide and this is your isocyanide. Okay. So we have seen the preparation of cyanide and isocyanide. Generally, the thing with the alkyl halide is we studied this thing in the starting of the 12th standard. The reason is you can prepare a lot of different compounds using your alkyl halide. You just take the alkyl halide and you can prepare different things. The thing is, this is because we know that कि आपके जो halogens हैं ना, they are good leaving group, right? They have a tendency जिसके कारण अपन उनके bonds break कर सकते हैं, right? So due to this nature of your halogens, this topic is very important. We have learned different ways where we studied how to get different products using your alkyl halide. We have seen कि hydrocarbons तो बहुत easily बनते हैं using alkyl halide. So using different alkyl halide, है ना, you can create different things. Okay. Next thing is your aryl halide. So we will discuss about the aromatic halides. So the aryl halide preparation is done via your electrophilic aromatic substitution. So aryl halides are the halides which are present onto the aromatic species. Okay. So simply अपन ने देखा था कि अगर अपन एक alkane लेंगे and we will simply do the chlorination or your bromination in the presence of H mu, है ना, simply आपका chlorination हो जाता था. But if you do the same thing with the benzene, let's say we are taking this benzene, ठीक है, यहाँ पे if you do the same reaction, you will see कि this reaction will not happen. And the reason is this benzene is very much stable, right? It is aromatic, तो ये react करना नहीं चाहता है. Sorry for this guys. Okay, so this is very this benzene is very unreactive. तो अपन ने देखा था कि in this process the first step is to create a R radical which will react with this Cl radical or Br radical to give the final product. तो यहाँ पे you cannot create a benzyl radical. This is very unstable. So that is why to form your aryl halides we use a different mechanism, that is your electrophilic aromatic substitution. So we will study about this reaction in a minute. So अगर किसी को कोई doubt है तो you can always ask me in the chat box. So on this page I have simply taken few examples to help you understand what is a electrophilic aromatic substitution is. So देखो, you just take any aromatic substance. So for simplicity I have taken benzene. I know that everybody knows that this is a aromatic species, ठीक है. So we have benzene, we are reacting it with a halogen, okay, in the presence of FeCl3. So FeCl3 is your Lewis acid that we are using. Okay, so simply this Lewis acid is helping this chlorine. देखो अपने को पता है कि दैट क्लोरीन जो मतलब जब आपके जो हेलोजेंस होते हैं दे हैव अ टेंडेंसी टू एक्ट एज अ इलेक्ट्रोफाइल और एज अ न्यूक्लियोफाइल. तो यहाँ पे क्या होगा ना, यहाँ पे क्या होगा कि दिस FeCl3 इज मेकिंग वन ऑफ द क्लोरीन टू लीव. सो दिस क्लोरीन विल टेक both of the electron to itself. So what can happen is, since देखो अपने पास जो बेंजीन है ना, this has a tendency कि ये एक डायरेक्शन में ओपन हो सकता है and this can act as a nucleophile. So this will attack on this chlorine. So this FeCl3 is increasing the tendency of this chloride, one of the chlorine, to leave. So यहाँ पे ना the reaction happens, this type of reaction is known as your electrophilic aromatic substitution. Similarly, you can use Br2. There are a lot of different Lewis acid that you can use. FeCl3 is one of them. FeBr3 you can see both of them in the here. Next you can use AlCl3. Okay, you can also use AlBr3. So you can use any Lewis acid to break this bond homolytically, since this Lewis acid is acting as a catalyst which is making this chlorine bond to break heterolytically. ठीक है. So this is the basic thing about electrophilic aromatic substitution. Okay, so here देखो simply we are using this AlCl3. इसका मैकेनिज्म आपको कभी भी नहीं आएगा, you just need to understand कि okay ऐसे ऐसी चीज़ें होती हैं. तो यहाँ पे this AlCl3 will make this bromine leave, creating a positive charge on this bromine. ठीक है, that will not be a partial charge, that will be a completely positive charge. And this double bond of benzene has a tendency to open up. So this will open up and attack this bromine. So once it will attack on this bromine, you will create a positive charge on this, right? So यहाँ पे you will have this thing. So आपके दो bonds तो same है, one of the bond has been replaced. ठीक है, यहाँ पे आपके पास bromine है and you will have a positive charge here. So once you have got this, what आपका क्या होगा कि since you can get a H positive from the solution, right? So simply no sorry यहाँ पे we don't need a H plus. What will happen is you have a hydrogen here, right? We know that aromatic compounds are very stable, right? So this compound will try to regain its aromaticity, right? So यहाँ पे this hydrogen can leave, giving the electron to this carbon. So the structure will look something like this. Here you have bromine, here you have positive charge. After leaving this hydrogen, you will have a negative charge. So you will have a double bond here instead. So we have restored the aromaticity of this ring. Okay, and you have formed your alkyl halide. Okay, so I hope this part of the reaction is clear. So this is the way how we create your aromatic halides. Now the thing is, देखो अभी तक जो अपन एग्जाम्पल ले रहे थे उसमें you have seen कि the aromatic compounds that we were taking, all of them were the benzene, right? Now if you have a group present on the benzene, so that will affect on the position where your bromine is getting attached, है ना? So इस ग्रुप से बहुत ज़्यादा फर्क पड़ेगा. So the thing is, we have studied the concept of inductive effect and mesomeric effect. So this group, that is your OCS3, this is a plus M group. Okay, so what does the plus M group does? So अगर आप इसका, if you draw the resonating structure of your this compound, you will understand कि आपके जो ऑर्थो पैरा पोजिशंस होते हैं ना, इन पे there is a slight negative charge on ortho and para. So these are the position where you have a slight negative charge due to the presence of OCS3. Okay, let's try to draw the structure here. Now the thing is, so what can happen is, ये जो structures है ना, आपका जो benzene का double bond है, it can either open here to create a negative charge here, है ना, and now this will act as a nucleophile. So you can either get this structure in which you will have a bromine here, a OCS3 here. ठीक है. This will again re-attains its aromaticity by losing this hydrogen. So you will get the aromatic compound. You will have a orthobromine. While you can also create a structure that will look in which this carbon is attacking. Okay, this carbon is attacking. In that case, you will form this thing. You will finally get the aromaticity back. So you will have this bromine. So this is, in this case, आपका bromine का attachment ortho position पे हुआ, while in this case bromine got attached on the para position. Okay. So this is the effect of a group if a group is present on either onto the ring of the benzene. ठीक है. So आपके जो प्लस M ग्रुप होते हैं ना, they are ortho para directing for an electrophile. This is very important. So here this bromine was acting as a electrophile which is having a positive charge. So for any electrophile, your plus M group are ortho para directing. That is, they will want these electrophiles to attack on ortho para position because of these groups that you have created a delta negative on these positions. So similarly, अगर ना आप एक nucleophile का attack करोगे ना in the presence of a plus M group, so this nucleophile will move toward meta position because meta is the only place जहाँ पे आपके पास negative charge नहीं है, right? So you don't have any positive charge, but comparatively those are the places जहाँ पे आपके पास less charge, less negative charge है. I hope all of this thing is clear to everyone. चलिए, so this is important कि आपके जो plus M group हैं they are ortho para directing for an electrophile. Okay, now let's take one more example. यहाँ पे we are using NO2 instead of OCS3. So we know that कि जो अपने जो NO2 है ना, these are minus M groups, right? So these are the groups which are taking electron from the system. So if you have seen the resonating structure of this thing, तो यहाँ पे क्या होता है कि these create a positive charge. So in the resonance, these create a slight positive charge on ortho para position. Since they are creating a positive charge on ortho para position, तो comparatively आपका जो meta position है is less negative than ortho para. Okay, it is less negative. So your meta position will act as a nucleophile. Okay, so this is acting as a nucleophile now. So यहाँ पे जो आपके जो डबल बॉन्ड्स है ना, तो वो पोलराइज इस तरीके से होंगे. So this bond will polarize toward this thing. So then this will attack on this bromine. So here the only product that you will get is NO2 and meta is bromine is here. So अपन ने देखा था in the case of a plus M group, you are getting ortho para products. ठीक है, even though your para will be the major product because of repulsion. Okay, but if you have a minus M group, what you will have is you will have a meta पे you will have the major product. So what do we understood from this is that is your minus M groups are meta directing for electrophile. Okay, so if you have a positive charge, it will attack on meta position if you have a minus M group attached to the benzene ring. I guess all of these things are understood by everyone. So these things were very important. अपन ने पहले we have seen the general mechanism of electrophilic aromatic substitution. We have seen the effect of different groups present on this ring. ठीक है. Next thing is what if we have a chlorine, that is if we have a halogen already present on the benzene ring. So what will happen in this case? Now the thing with chlorine is, okay, now the thing with chlorine is that yes, they have a tendency, okay, but they that chlorine are orthopara-directing, even though they are deactivating the ring, that is they are taking the electron from the benzene ring, still they are orthopara-directing. देखो क्लोरीन का माइनस आई होता है बट प्लस एम होता है. सो ड्यू टू दिस माइनस आई, this chlorine is pushing electron from the benzene ring, it is deactivating the benzene ring, but it is orthopara-directing, that is it is pulling these electrons more, that is equally from all of these positions. So still your orthopara positions have that delta negative on them, ठीक है, because it is a plus m group which can donate. देखो in the case of halogens आपका जो इंडक्टिव इफेक्ट है ना, उसकी पावर इज मोर देन योर एम इफेक्ट. बाकी सारे एलिमेंट्स में, बाकी सारे कंपाउंड्स में आपका मेसोमेरिक इफेक्ट इज मोर डोमिनेंट, बट फॉर द हेलोजेंस आपका इंडक्टिव इफेक्ट इज मोर. सो इवन दो इट इज अ प्लस एम ग्रुप, it is deactivating the benzene ring, but since it is a plus m group, what it will do is it is orthopara-directing. So if you have a chlorine already bonded to a benzene ring and you are adding a chlorine to it, so you will get the orthopara product, that is a chlorine here, a chlorine on the para position plus this thing. Again your para will be the major product. So I hope all of these things are clear to everyone. So these are the different reactions that we have seen. We have seen the reactions on normal benzene, ठीक है. We have, after that we have seen the reactions when we have a plus m group, we have a minus m group. देखो यहाँ पे this is minus I, right? This is minus I, this is again minus I. But generally we don't talk about minus I because आपके जो mesomeric effect होते हैं ना, they are very dominating. But in the case of halogen, this is plus m and minus I. But here your minus I effect is the dominating effect. Okay, so that is why you need to understand कि यहाँ पे this is deactivating the ring, this is pulling the electron from ring. But ना ऐसा नहीं है कि ये ऑर्थोपैरा से पुश कर रही है, ये मेटा पोजिशन से भी पुश कर रहे हैं through inductive effect, but through mesomeric effect they are providing electrons to ortho and para position. Okay, while यहाँ पे NO2 के केस में क्या हो रहा था कि दोनों तरीके से पुल ही कर रहा है. ओके, एंड यहाँ पे आपका mesomeric effect was more than your inductive effect. So that is why आपका यहाँ पे orthopara होगा. यहाँ पे this is also orthopara, this is meta-directing. यहाँ पे तो you can have a normal electrophilic aromatic substitution. Okay, so all of these things have been covered. I hope you guys were able to understand these things. Next is this reaction. This reaction is very important. We will discuss this reaction in very detail in our tomorrow session. Tomorrow we will be discussing about the Sandmeyer reaction. We will talk about your SNAR reactions. So this is an example of SNAR reaction. So what is happening here is we are taking aniline. We are starting with aniline. Okay. So this is again a method. This reaction is a very vast reaction. This can be used to prepare a lot of different aromatic reactions, aromatic compounds. But since we are studying this reactions in the chapter of alkyl halide, so we will try to understand how we can prepare alkyl halide using your Sandmeyer reaction. So in the first step, what we are doing is we are adding NaNH2 in aqueous HCl. This is very important, in aqueous HCl. So what here we will create is we will create a species that will look something like NO. ठीक है, this NO will attack on this nitrogen. We will see the mechanism of Sandmeyer reaction in a while. मैं आपको basic idea दे रहा हूँ. So this will attack, and finally somehow you will create this species that is known as diazonium salt. Okay, so you have positive charge on this nitrogen and you have chlorine here. One important thing about this reaction is this is done at a very low temperature, 0 to 5 degrees Celsius. Okay, because the thing is, जैसे आप temperature increase करोगे ना, this NO2 has a very good tendency to leave. It will leave, creating a positive charge on this carbon. So अपन ना इसलिए क्या करते हैं, we try to keep the temperature at a very low. ठीक है, and once you add a CuX, this can be CuI, CuBr, CuCl. Generally this is not preferred for your fluorine, so we use different reagents for preparing your aromatic fluoride. So यहाँ पे you will be using these three to form this reaction. So this reaction is an example of your SNAR reaction. So we'll see those reactions in our tomorrow session. Tomorrow will be the last session on alkyl halide. So guys, tomorrow at 4 p.m. again I will be live with the last topic of alkyl halide. Chali, moving on to the next thing. Let's try to understand the reaction mechanism of this Sandmeyer reaction. This is not that important, but देखो मैंने बोला था ना कि that we create NO using your NaNO2 and HCl. Okay, using this we are creating NO. Okay, so once you have created NO, this NO, and we have aniline in the solution. So what can happen here is this nitrogen having a lone pair, this will attack on this nitrogen, ठीक है, and this bond will open in towards the oxygen. So you have created this, and after a couple of steps, simply देखो यहाँ पे there will be a lot of different concerted reactions, ठीक है, which are not in our syllabus. फिर भी I have shown you this reactions. Okay, so देखो you have a double bonded oxygen. From the solution you can add these hydrogens to this oxygen. यहाँ पे जो hydrogen है ना, this will leave and will attack on this oxygen to create this thing. Again one more hydrogen will attack to create this thing, and this will leave to create your final thing, that is your diazonium salt. So this reaction mechanism is not that important, but the only thing here is you just need to understand that it is done at a very low temperature. Okay, so after we have created the diazonium salt, इसके बाद you can have a lot of different reaction with your diazonium salt. So since this is a chapter of alkyl halide, we'll be focusing on the preparation of alkyl halide. We have seen that we can use COX to prepare your aromatic iodide, bromide or chloride. Okay, ठीक है, this thing was very important. ठीक है, it's very important that this is a very good leaving group, because it will release into N2 and it will evaporate, right? So it is a very good living group. That is why we keep the temperature around 0 to 5 degree Celsius. Okay, so देखो, this is the brief about your Simon reaction. अभी अपन ने देखा था, we have seen the preparation of chemical to form. चलो, this will be the last thing of our today's session. After this I'll be ending our today's session. In tomorrow's session we will be solving these bunch of questions, and we'll be starting the process of SNAR. Okay, so here what is happening is we have the structure. In the first case we are doing chlorination in the presence of light. ठीक है, तो आपको बताना है कि what will be the major product in this case. Now the thing is, देखो, since we have done a lot of reaction mechanism in the past 5 to 6 classes, so I hope everyone have understood that. So since we have done a lot of reactions and we have did the reaction mechanism, so once you will be thorough with the reaction mechanism, you can easily predict what will be the major product. So since we know that this is the free radical reaction mechanism which creates a chlorine radical, right? Now we have seen you cannot take these hydrogens out, right? Because it will create a carbon free radical on a sp2 carbon, which is not that stable. So in that case what you need to do here is यहाँ पे you will create this radical, that is CS2 radical, and in the next step a chlorine radical can react with it to form CH2Cl. While if you use chlorine in the presence of a Lewis acid, अपन ने देखा था कि this reaction is your electrophilic aromatic substitution. यहाँ पे you will create this as the final product, CH3. You will have ortho para product, both the product. We know that कि CH3 is a plus I group, है ना? It is a ortho para directing group. Okay, I will see the chat box once. चलिए, सो यहाँ पे अपन ने देखा कि हाउ डिफरेंट रिएक्शंस, हाउ डिफरेंट रिएजेंट कैन लीड टू डिफरेंट प्रोडक्ट्स. यहाँ पे वी हैव एडेड दिस क्लोरीन ऑन दिस कार्बन, वाइल यहाँ पे आपका एरोमेटिक सब्स्टिट्यूशन हो रहा है, राइट. तो यहाँ पे वी वर क्रिएटिंग ऑर्थो पैरा प्रोडक्ट बिकॉज योर CH3 इज ऑर्थो पैरा डायरेक्टिंग. So these questions are homework for you guys. I have taken a lot of sessions in my special classes too, जहाँ पे we have solved a lot of questions. So I'll be taking few more classes in the upcoming days. Right now, if you have any doubts regarding this chapter, let me know. Tomorrow at 4 PM will be the last session on alkyl halide. उसके बाद अपन alcohol start करेंगे, ठीक है. From what is the date today? It's 12th, right? So from 14th we'll be starting alcohols. Okay. And tomorrow in my special class, that is at 2:30 PM, we'll be solving questions on periodic properties. Okay. Chali, with this I'll be ending our today's session. Thank you guys for joining. So please subscribe to the channel, which is Let's Crack JEE. Okay. Use my code AC01 if you want to take any of the plus subscription or the iconic subscription. I will show you the tab once again. ठीक है, we have discussed about the prices. So this is, you can take a 1 year plus subscription. It will cost you 34,650 once you use my code, which is AC01, and it will cost you 50,400 if you take a 2-year subscription. So आराम से choose करो अपने लिए, like whichever subscription you feel like will help you. Okay, and you can also take the iconic subscription. With the iconic subscription, the price is 50,400 for a 1-year plan, and it is 77,400 for a 2-year plan. So again, this code AC01 is providing you with a 10% discount. Chalo, I will end our today's session, guys. Yeah, Manas Ahuja, hi. I was about to end the session. So if you have anything to ask, you can ask. So guys, that was it for today's session. अगर आपको कुछ पूछना है तो you can ask. So we have done a lot of reactions in today's session. We have seen the coupling reactions. ठीक है, just go through the video once, and if you still have any doubt, let me know in tomorrow session, that is at 4 PM. अपन ने बहुत सारे चीज़ें कवर किया आज. Okay. So these questions are homework for you, first, second and third. Chalo, since no one has anything to ask, I'll be ending our session. Bye bye everyone.